Well, welcome back. This is part two of our intro to virtual work for trusses. So what I'm gonna do today or now is work a problem for you using the virtual work method. And we're gonna use SAP 2000 to find the solution. So let's first, I'm gonna go and share my screen. So there we go. Before I go into the SAP 2000 part, let me show you the problem. So here's the problem that we're going to do. This is problem 8.7. So we're going to find the displacement at joint A, which is here, the vertical displacement, which is down. And you can see there's all of our dimensions. We're in feet. Also, there's the cross-sectional areas you can see. And then there's our value for E up here, 29 KSI. So we're going to first enter this truss, the geometry, but I'm going to show you something a little unique today with SAP 2000, how to have multiple load cases. So we're going to find the real load system, which is this 6 kip and 3 kip force, and the virtual load system at the same time. So let me go back to my SAP 2000. Here we go. So we're going to create a problem, a new model. And you can see we're in pounds and inches, which is going to be fine. So I'm going to do a grid-only model to get started. So in the X direction, you remember is our horizontal direction, we're going to need 3 grid lines to map this model, 3. On the Y direction, we'll just need 1 as normal. And the Z direction, we'll need 2. Now the spacing for all of these is 8 feet. Remember, we're working in inches. So 8 feet is going to be 96 inches. So that'll be in the X and Z direction. Okay. So there's our grid. So I'll get rid of this one. We'll have the one system. I'll go into the XY, XZ space. There we go. And now we can, let me make it, see if I can make it a little bit bigger. Oh, that maybe is a little bit too big. Let me go full screen here. There we go. So there it is. So let's put our nodes in first. Remember, you come over here and click on the special draw joint. And then I'll come and click the 3 nodes along the bottom. I'll get rid of this. And then across the top. So those are the 5 nodes defining our structure. And then we'll click on the fourth button, which is the draw frame. And we won't worry about that right now. And we'll go ahead and then click and draw our frame elements. So there's some of those. And then we've got one from here to here, and from here to there, and from there to there. So I've drawn the geometry of my structure. I'll just flip back to the drawing so that you can see it. Here it is. So it looks like we have a pin at the upper right-hand corner and a roller here at B. So let's do those next. So I'll flip back. So up here on the right side, I'll select that, and we'll go assign joint restraints, and that'll be fast restraint, a pin. And then I'll pick this bottom node here, and again go assign joint release, and that'll be our roller. So we've got our supports. And next there's 2 loads applied. So I'll flip back so you can see that. So again, on the far left node, there's a 6 kip or 6,000 pound, and then here at C, 3,000 pound. So we'll go back to our screen here. So I'll pick the left side, and we'll go assign joint load force, and that'll be in the global Z direction, and it'll be down, and that's a value of 6,000, so I'll say minus 6,000 pounds. Apply that. There it is. And then over here at C, it's 3,000 pounds. and apply that. So we've got our two loads. Okay, so the new thing that I want to do is, you notice these loads are in what's called the dead. So I need to create another load system for my virtual load. So under define, we'll go down to load cases. Load patterns. You can see I've already got a dead load. So now I'm going to type in virtual, and I'm going to add that. So now I have a dead load case and a live load case. And really, I can rename the dead just to make it easy for me to remember. So I'm going to click on dead and come up here and call it real. And then I'll modify it. So now I have two load cases. You can see real and virtual. And that's all I have to do. I'm just naming them. So back in the system here, just to make sure I've got the right ones, I want to go display, show load, joint, say yes. And now you can see I have a real and virtual. I'll just say real. And you can see there's my real systems as before. So now I want to do my virtual system. So let's go back and look at the problem real quick. So you can see in the problem, I want the vertical displacement at A, which is here. So I want to put a vertical load here at A equal to 1. So now I'm going to select that load. I'm going to say assign joint load force, except this time I'm not going to do the real system. I'm going to do the virtual system. And it's not going to be minus 3,000. It's going to be minus 1, the virtual load. So I'll move that over so you can see it. And I'll apply that. And now you can see there's my 1 virtual load. All the other real loads are gone. So I have 2 load cases. Now from this point on, we can go ahead and proceed like we normally would. So I would go ahead now and look at my analysis and set my options and say I want to do plane frame. Say okay, done that. I want to select everything and assign frame releases. This is we'll make it a truss. So remember, I'm going to turn off torsion and my moment capacity at both ends. Okay, so now you can see I've got pin connections everywhere. So now what I need to do is assign those cross-sectional areas. But really, I don't have to worry about that, okay? The area and the E value will come into our calculation. Remember, when we do virtual work, we're going to sum up real, virtual times length divided by AE. Here in SAP 2000, I don't have to do anything. I'm just going to find the forces. So I'm pretty much ready to go. So I'll come up here and say run. It's going to ask me for a place to store this. So remember, don't forget, I'm going to go to this PC and I'm going to put mine on my desktop. I'm going to create a folder to keep all my SAP 2000 work. And in that folder, I'm going to save it as, this is problem 8-7, and I'll put spring 20 on there just to remember that. Say okay. So it's running. See, my wheel is spinning. Okay, we're done. And as you can see from the animation, that looks like a reasonable movement for the real load case. So I'll stop that. Now, I need to get my forces. This is such a small truss that I may be able to just go and say, I'll look at my frames, and I just want my forces, the axial forces, and I'll say from the dead load, okay, and there they are. Oh, I forgot to put on the values. I want to have show value. Okay. Oh, I know what I forgot to do. I forgot to turn off the, you can see these loads are huge. So what I forgot to do was make a truss material That's dimensionless. So right now I have a huge steel truss. So let me unlock my system and go back and let's define a material. We can call it this one, the steel one. I'll modify it. And we want to make sure it has no unit weight for right now. So I'll say okay. So that's the steel model. And of course, need to define my frame section, which was the default frame section. There's only one. And when I modify that one, you can see I am using the steel. And you can see it was a huge cross section. So that's why my values are so large. Okay, so I've corrected that mistake so I can rerun it. Ah, that's much better. So there's my real forces in the system. So I'm going to have to make some calculations. So I'm going to go ahead and start up a spreadsheet to do the calculations. And I'll get a new spreadsheet. And I'll slide that one over here to the side. And I'll try to have my SAP model over here on the right. There it is. So I'm going to make a title. I'll just call it frame. And I'll go through all my frame elements. So I have one that's AB, and then BC. I'm just going around the edge. CD, DE, and then back to EA or AE. That's around, and then I'll have the vertical one, which was BE, and the other diagonal, which was CE. So there's my frame elements. And I'm going to get the length. I'll say that's in inches. So what is the length of AB? Well, I think I'll wait for that. I think I'll get the real values here first. So in our notation, that would be capital N, and those will be in pounds. And then I'll get the virtual forces, lowercase n, they have no unit. And then I'll get the length, which will be in inches. And then I'll get the area, which is in inches squared. And then, of course, I'll form that product, real force, virtual force, length divided by A. And E, actually. So I can go up here and put in my common value for E, which, you know, oops. E, and that's going to be 29, 1, 2, 3, 1, 2, 3. So that's 29 million PSI. And I'll just go ahead and leave that number like that. So let's go put my real value. So you can see over here, AB is minus 6,000. And then B to C is also minus 6,000. And then C to D is minus 3,000. And then D to E, is 0. That's this element here. Then this element here is the diagonal. That's the EA or AE value, and that's 8485.28. And then BE is the vertical one here, which is minus 12,000. And then the diagonal CE is the same number as AE. So I'll just do a quick copy and paste. So there's my real values for all those. I'm gonna go ahead and select all this and just tidy it up, make it centered. There we go. So what are the virtual values? So I can, over here, I can go to display, show load, show element loads at the joint, and then choose the virtual system. Whoops. That's not what I wanted to do. Let me go back to full screen here for just a second so I can get my my values back. I wanted to go here and show my loads in the frame, but not for dead, virtual. Apply that. There we go. So now we can go back here and let's shove this over there. Give it a second to, oh, it didn't fill the screen all the way. There we go. All right, so let's now do the virtual loads. So again, the whole bottom is -1, -1. And then CD is also -1. DE, again 0. AE is 1.41. VE, that's this vertical one here, it's -2. And then finally the other diagonal is also 1.41. All right, so I have all my forces. So let's do my links. Well, everything is 8 feet. So these first through are going to be 96, 96, 96, 96. So AE is my first diagonal. I'm going to have to do a quick calculation. Let me get my calculator here. So that'll be 96 times the square root of 2, which is 135.76. And then BE is vertical, so that's 96. And then this last one will be the same value, 96 times the square root of 2, 135.76. So I've got all my bits and pieces there, so I'll make that a little bit bigger so we can see it. Go full screen on that. No, not letting me go full screen. Let me try it again. There we go. Now the areas, if you go back and look at the value here, you can see 3, 3, 3, 2, 2, 3. So I've got, those are my cross-sectional areas. So the first one will be 3, and then 3, then 3. And across the top now is 2 at DE. The diagonal is 2. The vertical is 3. And the final diagonal is 2. So now we have all the pieces that we need. So let's make the calculation. So we'll say equal to the real load times the virtual load times the length divided by E. I'm going to make sure I get the absolute references on there, times, it's covering up here, but that's going to be G6. I'll just type G6 in. So there's the calculation. Let you look at that again. So you can see D6 times E6 times L6 divided by E, and then A and G6. I should just be able to copy that. And then the final value here, which will be my solution, I should just need to sum all these values. And that should be in inches. So I'll just quickly put a box around that and make it green. So give me just a second to check the solution for 8.7 in the back of the book. Make sure we've got the right solution. So 8.7 is 0.0992 inches, and that's what we got, 0.099. That's close enough. And I got a positive value, which means if you look back at our solution here, remember that we, if I go look at if I display my load case, in this case, the joint load, and I look at my virtual system, you can see I applied that load down. So I assumed that it was going to go down, and by getting a positive value, I did get that. Let me turn off the grid and the axis so you can see the negative load is down. So it did go down, and that's correct. So that's the way to do that. You can see this would be a difficult problem to do on the exam, but I'll give you some of these to do for homework. So really all you have to do is get the solutions from SAP 2000, then enter the length and the area, and then just do this calculation as we've shown here. Let me see if I can do a little bit better job of showing you the solution. There it is. So again, real force, virtual force times length divided by EA. Pretty simple calculation. Okay, so I'm gonna stop sharing my screen, come back to you. So let me know if you have any questions with this. We'll proceed. So this should get us through the week. And again, if you guys let me know that we're having some issues and I need to have a Zoom meeting where we can contribute, or you can come in if you like, just let me know. If I don't hear from you, we'll just proceed this way. So check the, what's it called? Oh, Mastering Engineering for your problems. And also I'm posting everything on the class website. So everybody be careful and take care of yourself. Bye.